The James Webb Telescope has just detected a remarkable 250% increase in the brightness of Betelgeuse. This red star, located at the shoulder of the Orion constellation, has been displaying unusual behavior, raising excitement for what could be an extraordinary event. Some experts believe that the increased brightness may indicate that the star is on the verge of going supernova, but the exact timing remains uncertain. Join us as we explore the mysteries surrounding this massive celestial body and uncover the secrets it holds. Betelgeuse has the potential to revolutionize our understanding of the cosmos. Even if you haven't heard its name, you've probably seen Betelgeuse, a brilliant reddish star marking Orion's shoulder. If Betelgeuse were placed at the center of our solar system, its outer edges would extend beyond Jupiter's orbit. This gigantic and easily observable star continues to intrigue astronomers. Unlike most stars, Betelgeuse changes visibly due to its relative proximity to Earth. Classified as a semi-regular variable star, its brightness varies, sometimes dramatically, as it progresses toward an eventual supernova explosion. Betelgeuse's recent fluctuations in brightness have made it even more fascinating, challenging our understanding of stellar behavior. What's causing Betelgeuse to shine so brightly and act so erratically? This is uncharted territory. The star's peculiar behavior began with an event in 2020. Betelgeuse experienced what is known as the Great Dimming in 2019 and 2020, which we'll discuss in detail later. This dimming event has now caused the closest red giant to Earth to pulsate at twice its usual rate, lighting up the early evening sky in the southern hemisphere. This dramatic fluctuation in one of the sky's brightest stars is providing scientists with unprecedented insights into the life cycle of massive stars. Recently, Betelgeuse has shown more than a 50% increase in brightness. On May 20th, 2023, Beetlebot, a Twitter account dedicated to monitoring Betelgeuse, reported an astonishing 142% surge in brightness, followed by a 150% increase according to the latest updates. Astrophysicist Andrea Dupre from the Harvard-Smithsonian Center for Astrophysics notes that Betelgeuse is now the 7th brightest star in the night sky, up from its usual 10th place. In the southern hemisphere, Betelgeuse is easily visible in the early evening, positioned at Orion's shoulder. It's also visible from the northern hemisphere as the days grow shorter. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, highlights that one of the most exciting aspects of Betelgeuse is the ability to observe the final stages of a massive star's life in real time, something never before studied in such detail. By observing Betelgeuse's behavior, we can learn critical information about the end stages of red giants before they explode as supernovae. When it finally does explode, Betelgeuse could become incredibly bright for about a week, even visible during the day, and possibly casting shadows at night. This has caught the attention of amateur stargazers and professional astronomers alike, all eagerly awaiting this remarkable event. Betelgeuse's eventual supernova, visible from just 650 light-years away, promises to be an extraordinary spectacle. Heidi Morris, a scientist at Los Alamos National Laboratory and president of Pajarito Astronomers, says that Betelgeuse has always fascinated people. Its brightness has been fluctuating for a very long time. Astronomers have long known that Betelgeuse brightens and fades in a cycle. This pattern was even observed thousands of years ago by Aboriginal Australian and ancient Greek cultures. Typically, Betelgeuse's brightness cycle lasts around 400 days, but currently it's changing every 130 days, as observed by Andrea Dupre. This unusual behavior started in 2019 after Betelgeuse expelled part of its outer atmosphere. These changes are not typical for Betelgeuse, raising the question, is the star about to go supernova? It's difficult to say, as this is entirely new territory for scientists. A paper by Dupree and other researchers from Harvard and UC Berkeley suggests that Betelgeuse might take another 5 to 10 years to return to its usual 400-day brightness cycle. The paper states that Betelgeuse has been different since the Great Dimming, showing changes in light and radial velocity. Despite this, Betelgeuse is a massive red supergiant that has lived a fast-paced and intense life. It's only around 10 million years old compared to our Sun's 5 billion years. Betelgeuse is in the final stages of its rapid evolution. When it exhausts its fuel, its core will collapse under its enormous mass, resulting in a supernova explosion that could outshine entire galaxies. This event is inevitable, but the timing remains uncertain. Historically, Betelgeuse has been getting redder over the past 20 years, according to Jason Ibarra, who studies stars and the history of astronomy at West Virginia University. This indicates that Betelgeuse became a red supergiant relatively recently in cosmic terms, suggesting it might take a long time for the star to deplete its fuel. According to current knowledge, Betelgeuse is unlikely to go supernova anytime soon. But what does NASA say about Betelgeuse's fate? NASA estimates that Betelgeuse won't explode for another 100,000 years. Heidi Morris advises against assuming the star will remain unchanged even over the next 10,000 years. We should remain vigilant and let Betelgeuse inspire scientific advancements. Although it's unlikely we will witness Betelgeuse's explosion in our lifetimes, Dr. Sarah Webb reminds us that nothing is certain. We should keep our fingers crossed and hope for some luck. It's essential to remember that we're observing Betelgeuse as it was over 600 years ago. In theory, Betelgeuse might have already exploded, and we just don't know it yet. This possibility exists, but is far from certain. Historical events have shown that expectations can be upended. Before 1987, astronomers believed only red supergiants could become supernovae. However, a giant blue star in another galaxy exploded that year, surprising the scientific community. There's still much to learn, and Betelgeuse might surprise us yet. By studying Betelgeuse and other massive stars, we can better understand these phenomena. Even without a dramatic explosion, Betelgeuse's current behavior is intriguing. Its oscillation between dimming and brightening reveals complex physics. The fact that stars can pulsate on human timescales is astonishing. Betelgeuse is now much brighter than expected based on its 400-day cycle, but there's hope it will return to this cycle. Currently, it's struggling, but Betelgeuse might explode sooner than experts thought. A paper published on June 2, 2023, challenges our understanding of Betelgeuse's evolutionary stage. It suggests that Betelgeuse is in a late phase, nearing the end of its core carbon-burning process. This stage converts carbon into heavier elements like oxygen and magnesium, contradicting the belief that Betelgeuse is still in its helium-burning phase. Once the core depletes its carbon, a collapse leading to a supernova could occur within a few decades. It's an astonishing prediction, but it's hard to determine the exact stage Betelgeuse is in. Stars' surfaces change little when they're close to exhausting their carbon. The study suggests the core collapse could happen within a few decades after carbon depletion, making Betelgeuse a prime candidate for the next galactic supernova, happening very close to us. Although the study didn't specify when carbon depletion will occur, it stated that most carbon is nearly used up, indicating a potential supernova within a few decades. Could we witness Betelgeuse's explosion in our lifetimes? It's uncertain. The carbon-burning phase can last over 1,000 years for a star like Betelgeuse. Additionally, this study hasn't been peer-reviewed yet, so significant changes might occur before it's published. But consider how incredible it would be if Betelgeuse went supernova. What would it look like from such a close star? When Betelgeuse goes supernova, it will be a mind-blowing event. Imagine the spectacle. The last supernova visible from Earth in our Milky Way occurred in 1604. But Betelgeuse is so close that its supernova will be incredibly bright, visible during the day for weeks. Current estimates place Betelgeuse about 548 light-years from Earth. Ancient Egyptian records mention a supernova resembling a second sun in the sky. When Betelgeuse explodes, it will astonish anyone fortunate enough to witness it. The initial signs of a supernova's arrival will be subtle but clear. Neutrinos, ghostly particles emitted during the star's collapse, will flood Earth, activating detectors worldwide. Then, high-energy photons from the expanding stellar debris will create a spectacular show. You won't need any special equipment, just your eyes. The star will gradually brighten in the night sky, reaching peak brightness within days. It could shine 10,000 to 100,000 times its usual brilliance. In 1 week, Betelgeuse will be the brightest object in the sky, outshining even Venus. Depending on the explosion's strength, the remnants could be as bright as a quarter or half moon, concentrated into a single point of light. You'll even be able to see it during the day. It will be bright enough to cast shadows at night. Predictions range from 15 to 250 times brighter than Venus, which is already the second brightest object in the night sky. Imagine the view. Betelgeuse's explosion would be a spectacular event, lingering in the sky for a long time. This extraordinary brightness will last around 100 days. For astronomers, it would be a monumental event, offering a rare chance to observe the aftermath closely and discover new insights. Eventually, Betelgeuse will fade over hundreds of days, disappearing into the darkness. But don't worry. Binoculars and telescopes will allow us to observe it longer. If you're concerned about any danger, don't be. Betelgeuse is far enough away that its supernova won't harm humans. History shows such events are dramatic transformations visible to everyone, eliciting global reactions. People in the past often saw supernovae as omens, and Betelgeuse's end could spark interesting responses. A supernova like Betelgeuse's would be impossible to ignore. Astronomer Brian Koberlein believes such a dramatic event could awaken a broader interest in astronomy, potentially rekindling civilization-wide curiosity. Let's not expect a sudden explosion like a bomb. There might be signs or smaller eruptions before the grand finale. Remember, Betelgeuse isn't the only red supergiant in our galaxy. Others like VY Canis Majoris might explode first. Statistically, the Milky Way should see a supernova every 50 years. Surprisingly, we haven't seen one in 400 years, though we've observed remnants of past explosions. Statistically, we're overdue for a cosmic event. It's just a matter of time before the next star dazzles the universe. Betelgeuse's Great Dimming. In 2020 marked a significant event. The star's brightness decreased by 60% in late 2019 and early 2020. Fortunately, Betelgeuse's brightness returned to normal by April 2020, but the reason remained a mystery. Initial attempts to understand this strange event were inconclusive until the following year. Skywatchers easily spot Betelgeuse, providing valuable observations. To gain a detailed understanding, scientists rely on observatories like Hubble. The unexplained dimming led to speculation that Betelgeuse might be nearing a supernova. This sudden decrease suggested a pre-supernova phase, capturing global curiosity. Unlike our Sun, Betelgeuse's massive size gives it a shorter lifespan. When Betelgeuse goes supernova, it will transform into a neutron star or black hole, depending on the material left. Many astrophysicists advised against jumping to supernova conclusions, suggesting ordinary phenomena like a cold spot or a dust cloud might explain the dimming. Astrophysicist Miguel Montarch from the Paris Observatory proposed a combination of factors. Using the Very Large Telescope in Chile, they captured high-resolution images in 2019 and 2020, revealing that convective activity and a dust cloud likely caused the dimming. From this, they produced a remarkable image of Betelgeuse's surface using the sphere instrument. Betelgeuse is so large that it appears as a disk rather than a point of light. Montargis, fascinated by Betelgeuse since childhood, explained that detailed images showed significant dimming in the star's lower left portion. This led to the conclusion that a massive dust cloud caused the dimming. A colossal eruption on Betelgeuse's surface expelled a huge mass, likely several times the weight of our moon. This unprecedented ejection might have been caused by a gas plume from within the star, driven by its 400-day pulsation cycle. The exact cause remains unknown. While Betelgeuse recovers from the Great Dimming, scientists closely observe its behavior. Although humanity had never witnessed such an ejection, similar events might be common throughout the universe. We could observe this with Betelgeuse due to its proximity, size, and Hubble's capabilities.